Let us now discuss two activities. The first activity, you take a drawing sheet, a white cardboard sheet, and you place a bar magnet at its center, and you draw a straight line passing through the two poles and also through the midpoint of the magnet. This line is called the magnetic axis, axial line of the bar magnet. Now you place a compass needle. Magnetic compass needle will have a north pole and the south pole, so that this will be having a magnetic needle at its center. Okay, so the north pole of the magnetic compass will be repelled by the north pole of the bar magnet, and the south pole of the compass box will be attracted by the north pole of the bar magnet. Take a pencil and note down the point where this north pole. Okay, then again you will have to place the compass needle. Okay, compass needle at some other position, remove from the previous position, and place the compass box at the dot where we have kept the north pole. And then you will see that next time the attraction will be like this. Like that, you shift the magnetic compass at various positions following the points which you have placed. Okay, so that the magnetic needle will be orienting in different directions like this. So what I told you is first what you have to do is, you see here, this is the magnetic north and this is the magnetic south. So here it was magnetic south and this is the magnetic north of the compass box. So initially drawing the magnetic axis, you keep one point, and at that point first you keep the magnetic needle such that the south pole of the magnetic needle will be attracted towards the north pole of the bar magnet. Then you keep a dot at the north pole of the compass box. Then you shift the compass box at the point where we have kept. Like that, if you continuously proceed, means the north pole of the magnetic compass, okay, the north pole of the magnetic compass is deflected in a particular direction. So this is the magnetic north of the compass box. So there is a particular direction along which the north pole of the compass box will be deflected. That is the direction of the magnetic field. Just now we have defined that magnetic field is the area or space or region surrounding the bar magnet. Okay, inside which any other magnetic substance as well as any other magnet also will experience a force. Now in the magnetic field of the bar magnet, what is being placed is a small tiny magnetic compass needle, or there is a magnetic compass box which is very small in size. So inside that there is a needle magnet, and when it is placed at one particular point, the south pole of the magnetic needle will be attracted towards the north pole, and the north pole of the magnetic needle will be pointing in some direction. So at that point keep a pencil dot. Then on the pencil dot you keep the compass box shifted. Okay, then again you follow the path of the magnetic north of the needle, and finally if you join all these points means this will be a curved line. So that direction of movement of this north pole of the magnetic needle will give you the direction of the magnetic field. Okay, the magnetic field is denoted by the symbol capital B, and it is a vector quantity. It is a vector quantity because it is having certain magnitude that gives the strength of the field, and that is also having a particular direction. Understand? There is a specific direction along which the magnetic field is acting, and the direction of the magnetic field is given by whom? The movement of the north pole of the magnetic needle. Understand? So magnetic field is denoted by vector quantity with an arrow head over it. B is the magnetic field which has both magnitude and direction. Therefore, it is a vector quantity. Okay, this is one activity. The second activity is very simple, and most of you must have experienced it in your lower classes also. So take a white cardboard paper drawing sheet and place a bar magnet at its center, and you take some fine powdered iron filings, iron powder or iron filings separated from sand. That black color iron filings you sprinkle on the cardboard irregularly in a random manner. and then gently you tap gently the cardboard, so that the iron filings will vibrate with jerk, and finally after some time it will align beautifully along a particular pattern, You can see that the iron filings will be arranging in a particular fashion like this, okay. So in such curved paths only the iron filings will be arranging. So at these points you can see that overcrowding of iron filings will be there, and this shows that the attraction is maximum only at the two end points called the magnetic poles. And as you go little away from this magnet, you can see that iron powder or the iron filings will be scarcely distributed, okay. So these are some directions along which the magnetic field is acting. These are called the magnetic lines of force. So these are the curved lines, and they are all starting from the North Pole and they are ending in the South Pole. So here you can see that the direction of motion of the magnetic north is from the north towards the south. Like that, here the magnetic field lines will start from the north and end in the south. So in this pattern only the magnetic lines are acting, and along the direction of the magnetic field lines only the iron filings will be attracted. So this is called the pattern of the magnetic field, and you will see that these are the directions of the magnetic field. So outside the magnet means they will be pointing from the North Pole towards the South Pole. So they are all terminating outward from the North Pole, and here they are all terminating into the South Pole. So did you all understand the two activities? In the first activities we are tracing the pattern of the magnetic field of the bar magnet using a compass box. In the second activity we are trying to trace the magnetic field pattern of the bar magnet by using iron filings. So from these two activities we are going to summarize very important properties of magnetic lines. This is very important. So properties of magnetic field lines, and these are called magnetic lines of force. Magnetic field lines are also called as magnetic field lines. So this is very important. First one is, you see that outside the magnet, from which pole do they start? North Pole. And in which pole do they end? South Pole. So outside the magnet, okay, they start from, the North Pole, and end in South Pole, and end or terminate in the South Pole, okay. But they are all closed curves and continuous curves. They are not discontinuous. They have to start from one point and end. They should complete the loop. So for that, inside the magnet they have to pass through. These lines are, they are starting outside only, but they are completing their journey inside the magnet. Means inside the magnet they have to move from which pole to which pole? South Pole to North Pole. So that is the second property. So inside, okay, inside the magnet, they move, okay, they move from the South Pole, to the North Pole, okay, to the North Pole. And you must understand one very important information, that here all these lines are that is starting from the North Pole and moving outwards here, and here they are moving towards the South Pole. You cannot see any two lines intersecting here, is it not? They do not intersect each other. That is the third very important property. So they do not intersect each other. Now, if they intersect means what will happen? If they intersect means what will happen if they intersect? Say for example here two lines are intersecting means, okay, two lines are intersecting means what will happen? So there are two directions. So there are two directions. One direction is you see that curved downwards, other direction is going in some other direction. So can the magnetic field have two directions at the same point? It is not possible. So if they intersect means there must be two directions. There must be two directions of magnetic field. Okay, two directions of magnetic field. And can there be two directions for the same magnetic field at the same point? So this is absurd. Absurd means what? Meaningless. So this is a standard question asked in the board examination. Why the magnetic lines do not intersect? What will happen if two lines intersect is the question. If two lines will intersect means at a given point there must be two directions for the magnetic field. So it is absurd means it is meaningless, because there will be only one north pole and one south pole for the magnet and only one direction for the magnetic field at a particular point. So they do not intersect each other. And the next one you see here. Suppose you take this is the curved line, okay. Suppose if you keep a magnetic compass, if you keep a magnetic compass at this point means then the compass needle will adjust itself tangential to the curved path, and this will be the direction of the magnetic field B. Like that, suppose if you take here this point, and if you keep a magnetic compass at this point means then this will be tangential to this point. Here if you keep the compass box means it will be tangential to that point. So the direction of the tangent or the tangent drawn, okay, the tangent drawn to the lines of force, drawn to the lines, magnetic lines of force at a point, okay. It gives what information? Gives the direction of the magnetic field, gives the direction of magnetic field at that point, okay. So at any point if you keep the magnetic compass inside that needle, inside the compass box will be tangential to that line of force. So the tangent only is the direction of the magnetic field. And the last one is very simple. Suppose you take this picture, where are these iron filings overcrowded? Only at the two end points of the bar magnet. This clearly confirms that the attraction or repulsion will be maximum only at the two poles. So here the poles have maximum, okay, that is a strength of magnetic field. Strength of magnetic field will be maximum, okay, will be maximum only at the poles, maximum at the poles only, okay. So these are all the properties of the magnetic field lines. Shall we read once very fast? Okay, good. First one is what? Outside the magnet, they start from the north pole and end in the south pole. So in the picture, these lines start from the north pole and end in the south pole. Since they are closed and continuous curves, they must complete their journey. Therefore, the second property is what? Inside the magnet, they move from the south pole to the north pole. Is it not? They are completing their journey back at the north pole itself. And the third one, they do not intersect each other. We can see that the lines do not interfering or intersecting with each other. What will happen if any two lines will intersect? I told you that at this point, if two lines are intersecting means if you keep a compass box means in which direction the compass box should rest, there will be confusion. So compass box cannot rest or compass box cannot show two directions at the same point. So it is absurd. So from this we come to know that the lines do not intersect. And the fourth point is what? The tangent drawn to the lines of force at a point gives the direction of the magnetic field at that point. And the last property is the strength of magnetic field will be maximum only at the poles. So my dear students, what is meant by magnetic field? Magnetic field is defined as the area or space or region surrounding the magnet, inside which Any other magnetic substance entering will experience a magnetic force. And inside the magnetic field, okay, if iron filings are placed and if the paper is tapped, means we can trace the pattern, magnetic field pattern, okay, of the bar magnet. Similarly, by using a compass, magnetic compass also, we can trace the magnetic lines of force. And then we have studied the properties of magnetic lines of force. Okay, today we will stop the lecture with this and we will continue in the next topic. Bye.